Okay, great. So we're just going to open up a blank Rhino, and to launch Grasshopper, we simply just type Grasshopper. It'll boot up. All right. So Grasshopper is broken down into our component tabs and our canvas. And these tabs are based off logic of how we're going to write scripts. So we have parameters, which are just basic parameters. It's usually a collection of lines or something that we've defined as a line. And math are simple, are math operations, constructing a domain, even some programming language we can start to assign to. You might have to brush up on some of your basic math stuff math skills, because it uses that logic. Sets, we'll talk more later in sets, but sets are how we start to manipulate the data, how we start to extract some of the important data that we generate. And vectors are all about the direction of things, so the direction or the coordinates of points or lines. And then we start getting into something more familiar, like in Rhino and AutoCAD and SketchUp, is curves. So we can start to define a line, or we can start to perform an analysis on a curve, or we start to extract points from a curve or generate curves. And then we can even start getting into the three-dimensional, where we start going into surfaces and NURBS and VREPs. And then they have a whole nother tab of meshes. Intersections of how we start to manipulate these forms, or how they start to interact with each other, so we can start to look at how a line and line interact, or how a surface and a surface interact. And transformation is simply how we start to manipulate the forms even further, and scaling and moving them or arraying them. And display is just how we display it through display the objects or points. Now, there's a couple ways we can start off. So we're just gonna make a point. So what we're gonna do is we're gonna just double click on the canvas, and it says enter search key, or search for keyword. We're just gonna type in construct point. It'll come up with the first thing. We can also use the tabs, and if we Control-Alt-Click on our component, it tells us where it's actually located as well. So what we could do is, if instead of double clicking and searching for it, if you don't really know what you're searching for, you could always go into your vectors tab, and you can go under point, and there it is, construct point. And we can click it, and that appears. So when we have our point component, and these are called components, we notice that there's a little green X. When we select on this component, it turns green. We deselect it, it turns red. This X signifies the point. Now, we can't click on the point. There's a distinction between the Grasshopper program and the Rhino program. We can't manipulate the Rhino stuff that's in Rhino that's being referenced from Grasshopper. Grasshopper is simply using the Rhino display properties, or display, to show what you're scripting. So what this component is saying, and I'm going to delete this other one. If you want to delete, you can just hover over, select it, delete it, click the delete key. But what defines a point? So we can hover over it, and it says construct point, construct a point from X, Y, Z coordinates. So just like how we 3D model, we're going to be using the Cartesian grid, and it's looking for an X coordinate, a Y coordinate, and a Z coordinate. And by default, we can see it's all set to 0. And that's why that little green X is there, is it's at the 0, 0, 0 coordinate system, or coordinates. So if we want to change that, there's a couple ways we can change. The first one is we can grab a slider. So if we go into the parameters, we can go into input, and we want to grab this. It's called a number slider. And when we click it, we're going to go over to canvas, click the canvas, there it is. So what the slider does, and we can slide it, and it gives us a number. So in this case, it's giving us a number between 0 and 1. It looks like we have 3 decimal places of numbers that we have. So we have a lot of opportunities here. So what we can do is we're going to edit this. We're going to give it just a simple 0 to 5. So what we're going to do is we're going to right click, and we're going to go to edit. It brings up a little command box. And what it's asking for right here is its current settings is set for floating numbers, and the minimum to be 0, max to be 0, and gives us a range. And it's currently set at 0.448. Let's give it, we want more of an integer. So we're going to click on that, and suddenly all those zeros go away because it's an integer now. We can also change it to evens and odds, but in this case, we're going to show just integers. And we like the minimum. Minimum works for 0, but we want to change to the maximum. So what we want to do is we'll just double click, and we're going to set it to 5. When we set it to 5, we're going to click this green box. And there it is. It changes now our range is 5. We have minimum 0, max 5. And we're going to click OK. Now our slider is set to a 0 to 5. We're going to plug this into the X. So to change the X input, we're going to click right here, and we see this little icon that pops up with an arrow. We're going to click and hold, and we're going to drag it to the X. And we notice now the slider's changed its name to X coordinates. And then when we move the slider, our point changes. We can, so let's also copy and paste this. Let's change the Y now. So we're going to have this highlighted. We're going to do a Control-C and a Control-V. And that copies and pastes the exact slider. And the exact slider is 0 to 5, just like our previous one. And the same thing, we're going to click, and we're going to drag it to the Y. And suddenly we can change it in the Y, and we can change it in the X. So we see that our inputs now is in our X is a 3, our Y is a 2, and the output is a coordinate, which is 3, 2, 0. We can also do the same thing and copy and paste it, throw in the Z coordinates, and now we actually have a point that's in three dimensions. You start to see how that changes as well. We can also make this parametric, where we can combine one slider that feeds into two inputs. So we can always hover over the Y, delete it, and we can click and hold the X and put it into the Y. So now we have one slider that controls two inputs. So it makes it more of a parametric point. So one reason why we know a point to construct a point we need coordinates, because we can hover over this and we can see a couple of things. We know that it's looking for an X coordinate, but also we'll see this black hexagon, which says 0.1. Well, that 0.1 is an icon, means it's looking for a number. We can go over to our parameters or our primitives, and we can see number right there. We also can change this without having any sliders. I'm just going to delete these temporarily, and we can right click over the X and say set number, and we can actually define a number. So we'll say 5, commit changes, and now this input is 5. We can do the same thing here. We'll do this at 3, and we'll do this at 7. So there's benefits for these two scenarios, as if by having a slider, you can generate more points. You can see at different options where the points could be. But if you want a fixed point that is not parametric, you can define it by these numbers. There's also a third way, and we can actually have Rhino help us out. So if we want a specific point in Rhino, we can actually draw a point, and we're going to go into our parameters under geometry, and we're going to grab point. Now, a parameter is just a collection of points. Actually, I got mixed up. Sorry. But you can start to reference the geometry from Rhino. So let's back up for a second. So what we have is we have this point here. We're also going to copy this over. We're going to get another point. We're going to get those sliders back. Copy and paste those. We'll just use the default. Move that side. So we can start to reference points from Rhino by using the parameter point, and it's just looking for a collection of points. So I could always use a point from Grasshopper, but I also reference a point in Rhino. So I can click on my point, right click, and it gives me an option of set point or set multiple points. So in this case, we're just going to set one point, and we notice now our Grasshopper disappeared. And now our Rhino says point object to reference. And we're just going to click on our point that we made in Rhino. So now that point is in Grasshopper now. So when we move this point over, we notice that that red little X follows it around. So it's referencing that point, the point's coordinates. We can also draw a line. So what defines a line? 2 points. So we can go into curve, and under primitive, we'll click down, and here it is, create a line between 2 points. You click that. There we go. And what defines that line? 2 points. It's looking for a start point and an end point. We can also always, I guess before, we can always double click on Canvas and type in line and see it's going to come up with the line parameter, but we want the line component. There's also a lot of different ways we can create a line, but the simplest one is the line between 2 points. So we're going to take this point and this point. We're going to click and drag into A. Oh, and one reason why this is orange, not gray, so we hover over, it's looking for data. So there's these components show up in 3 colors. They come up in gray, which means it's working. Orange means it's warning, it's missing data. And red is saying something failed. And sometimes these, even though it says failed, it will show up orange. It's just how it's translating the data. Sometimes you'll have things that go up as red, but technically it still works. It's just there's something in the red there's something that's happening in the background that's saying this isn't working up to this point, but everything else is fine. Sometimes that happens. It might happen to you. As long as it's fine, it doesn't mean like the script doesn't work. It works. It's just when you have too many red components, the script will stop working, or if you have too many orange components. But this will start to turn gray once we fill in the inputs that it's looking for. So we're going to click and drag point right into A. And then we're going to click and drag point into B. And see, it generates that green line. And also, when we can notice that when we start to move this point around, it updates that line. So we can start to move things around, and that line will stick to that. We can also generate another line by using our other point. So we'll grab this line, or this point. We'll grab another line tool. Put this one to this line, this line in there. So now we got 2 lines. One that's being controlled by a slider 2. One that's being controlled by referencing a Rhino, and one that's fixed using coordinates in Grasshopper. So we can also start over. We can also start to create curves. So maybe we create a couple. Let's grab a couple points. And we're going to get our point parameter. So very similar to Loft, clicking the order of the points matters, or the order of the points up here. So if we right click and instead of setting to 1 point, let's set to multiple points. We're going to click here, here, or enter. So now all these points are in this 1 point parameter. And we're going to grab a interpolate. Actually, yeah, interpolate. And what this is looking for is it's looking for vertices, which are points. We have degrees of the curve, which talks about how curvy it will be. That one I don't use. And then how often the points that are distributed along the curve, the newly generated curve, which usually P and K, I rarely use. It's usually V or D I use the most with, but occasionally you'll mess around with those. But we're just gonna click and drag, and that generates a curve that hits all our points. So we can start to move our points, and that curve will update. Now, sometimes if I just want to see this curve, like these green X's are getting in the way. Well, there's a quick way to deal with that, and that's right-clicking on the point and click preview. So that turns off that component. A strange thing that it took me a while when I was first learning Grasshopper is your components are always going to be on. You can turn them off, but when you turn them off, they are turned off. And sometimes when you have a complicated string, it's relying on that point and it turns off, so it stops your script. But visually, sometimes it gets confusing. There's a lot of things going on. So you just want to turn off, you just want to unpreview this. So it's always going on in the background, this script. It's let's say I want to move this over, or I want to copy this over, this line. Well, you can't copy something in Grasshopper. The closest way to copy something, or to copy the way that how we're used to in 3D modeling, is called a move. And that's just moving the object from along a vector. So we're just gonna, and so when we move, it's looking for a geometry, which can be a curve or B-rep, or it could be a mesh, could be any geometry, and then T, which is the translation, which is a vector. Its default is 10, so it's 0, 0, 10. So we want to move our curve, and our output is the resulting curve, the length of the curve, and the domain of the curve, like where it's from the 0, from like where it is domain-wise on it, which we can get into a little bit later. But we just want to copy this over. We're going to take the curve, and we're going to click and drag right into the geometry. And just by default, it's going to just move this up 10. So you notice that it didn't move it, it copied it. It's because it's because all these run at the same time. If I want to just show that it moved up, well, I just have to unpreview my original curve. But this is where it's parametric is in Rhino. I would have to, if I want to change this curve, and I have all these points right here, I would have to undo it, and I would have to move my points around and then move it back up. Well, with Grasshopper, since everything is technically turned on and the data is flowing, I can always move these points, and I don't have to redo that command because that line is still being showed up. So let's say if I wanted to, let's draw another line. draw another line. Just grabs a few points. Really simple one. We're going to do the same thing. We're going to double click, grab a point, click multiple points. This time, we'll click that. There we go. Click and drag. There's that. There's our new curve. I'm actually going to move this up. Get these going. Here, we're also going to and we're going to hide these points. It's also good practice too, is to use our layers, because we can always use our references, so we can highlight those points. We're going to go into our layers. We're going to make a new layer. We'll just say GH. Maybe we'll change the color too. We'll get that to be red. So these will be our orange points. These will be our red points. Great, and we're just going to temporarily turn these off so we don't see them. We're going to unpreview this one. Okay, so what if we wanted to draw lines that are that span between these two? Like maybe it's like a roof or a truss or something that we're making. What we can do is there's a command called divide curve. There it is. When we start to type in divide, pops right up divide curve. And then it's looking for a curve to divide and the number of segments. And if we want to split the segments, which is fine. We'll leave that one. We'll keep that as false. We don't need that information. We really just want to span lines between them. And what do we need to create a line? We need points. So that's why we're dividing the curve into points. So we're going to take this curve, and by default it's set to 10. So we're going to go to 10 there. So there's that. So when we did that, it took our curve and divided it 10 times along its length. We also increase that if we want to double click and maybe we say 15. When we type in 15, it gives us a slider that has a range between 0 and 100, and it sets it at 15. We can also do that we can also double click and type 1, and it gives us a slider that goes 0 to 1. But in this case, we'll keep this one, and we'll click and drag and put it into N. We notice now we just gained 5 more points. And our output when we divide it is the points along the curve, the tangent, which is the direction, and the division points, which is like the location of them. It's essentially kind of the location. It's how the intervals that it's divided at. we're going to another divide curve. There it is. We just divided the other one, and we're going to do the same thing as 15 on this one. And we have our points here and our points here. So let's bridge get our structure going. So we're going to double click and we're going to grab our line. And there it is. It's defined, a line is defined by 2 points. I still want to grab a panel tool. Panel tools helps just show you the output of this. So the output is the output. The output is the coordinate system of all these, is the X, Y, and Z value of all the points that are divided up on this curve. You see that it goes all the way down to 15. Even though, also the tricky thing about Grasshopper is 0 does count as something. 0, it just doesn't ignore 0. So there is a point that it references here that they count as the 0 point. But all these are the coordinates that make up this, make up these points. The same thing with the other one. There's all our points. So what it does is we can now take just 1 point or take 2 points and use those 2 points to create one line, or when we have a whole list of points, and this is considered a list, we can use those lists of points and plug them into A, and we can take these lists of points and plug them into B, and it generates a line at all of those points. Delete that. Maybe point A, or put in point B. So what it did was, instead of doing just a one-to-one, it took that whole list of them and automatically generate those lines with it. And let's bring back our other points. We can also start to manipulate this, and those lines automatically update. So this becomes really useful when when we want to see multiple design iterations, or we're prototyping something and we're just rapidly producing stuff. We can create a lot of different design iterations from this. And we don't have to go back over and remodel everything like we had to do in Rhino or SketchUp. So another way we can do this is we can also create really simple forms. So if we do, say, type in box, actually we'll do rectangle. Just do a simple 2D rectangle if we have to. And we can always find that in the curve section under rectangle, or curves primitives. So to create a rectangle, it's looking for a base plane, and what it means by that is it's just looking for an X and Y coordinate. So so it could be, going back to our Rhino, it could be, and we see it a little bit here. Let me change my display. It could be the XY plane. It could be the ZX plane. It could be the ZY plane. It's whatever direction we want to draw that rectangle. So for this example, we'll just do the default, which is the XY. And to create a rectangle, it's looking for an X domain. Now we don't have to give it a domain, we can give it a value. And it's also looking for a Y value. And then we also can add a radius to the end. So that's an additional option. But we're just gonna give a Y. So even though it sometimes it will say like a domain, it's really just looking for numbers for the X. So its default is -1 to 1 and -2 to 2. So that's why we see more of a rectangle, because it's taking we're taking the 1 and we're taking -1. We're taking +2, we're taking -2, and it generates a box from that. When we can just plug in a singular number, and by default, it'll make the range 0 to whatever that number. So we could just say 15, plug it into X. And we're gonna grab native. There we go. So it kept the Y domain of -2 and 2, but it did 0 to 15, so it stretched it. And there it is in green. I'm gonna hide this other stuff so it doesn't get in the way. A quick way, if you have a lot of stuff that's on, that's just like, hey, I want it on still, but I just visually get rid of it. You can click and drag, and with a center mouse button, it comes up with this. You can just unpreview all, disable all, and it just turns it off. Or visually, it unpreviews it. Doesn't turn off, unpreviews it. We'll turn off that. So let's go back to our box example. So we have a 15. We can make it, grow it any way we want to. We'll grab another, copy and paste it. There it is. So wow, now we have our rectangle that can grow pretty big. We can also, so even when we hover over the outputs, the output rectangle, and gives us the width and height of it as well. And that's our rectangle length of the rectangle curve. But so let's say we generate this rectangle and it's a room, and we want to know the area of that room. I'm just gonna do this for visual purposes because it's hard to read. So we want to find the area of that. We can just type in area, or we can find it under surface under analysis. But we can now click and drag our rectangle into our area component. And now you notice that a point appears. And it's like, well, why does that point appear? Because the input is geometry, and the output is our area, which is 609 square inches. Now it's square inches because our units in Rhino is set to inches. So always keep that in mind, that whatever units it pops out, it's always going to be affiliated with the units with Rhino. And and another output is C, is the centroid, the center of the geometry. So if we want that point away, we can right click, unpreview it. If we want to display the area of this, we can always double click, type in panel, and a panel tool. And there it is. There's our 600 or 609. We can also, panel tools are a great tool because what we can do is we can always type stuff in as the top of it. So we always say area. And we can also, it can be a great output display. We can also copy it. We also use it as an input. And if sometimes if something is, now, here's a really important thing about Grasshopper, that the logic is always forward moving. You can't backtrack this and make an infinite loop. So I can't take this area and feed it into my y, because then it creates an infinite loop and it doesn't work. Because if I do that, everything goes red. It's like, wait a second, it doesn't make any sense. How can I'm feeding the information that I'm outputting, can't feed back into the input, because if there's no data, then I don't get, it doesn't work. So it's always a progressive logic that goes on. So we're going to plug that back in. So it's always moving forward. You can split things off. So I could always like now take the area of this if I wanted to and make a panel. And I could always reference this centroid for a different object, but it's never like a loop. It doesn't work like that. But I can use these panel tools as inputs to help if I wanted to, instead of using a slider or reference something in Rhino or setting a fixed number there. I could always right click over this, and I can always say disconnect area. And so now there's no data, and I can double click on this, delete that, and type in 5. Now it's really important not to click enter, because when you click enter, that's actually an input. That's actually something that you've created, essentially are creating a list. So you don't want to do that. You just want to click 5 or whatever number, and we can actually plug that in right into Y, and we can use that as a parameter, or as a parameter. So this function is really like if you remember matrices in high school, that's what lists are essentially they're matrices. They're just a list of numbers. So these lists of numbers, I can multiply, I can divide them. So just a quick example. We want to just generate a really quick list. There's a component called a series. A series can also be found at our sets. Our sets are always something that are generating numbers. So what a series does, and notice that nothing appears because we're not creating any new geometry. We're just getting numbers. We're just generating these numbers. So what a series is creates a series of numbers. So the inputs are first number in the series, the step size of each successive number, and the number of times it does it. So we'll start at the default is 0, but we'll still plug in 0 if we want to change this. The number of steps, we're going to say 1. And we're going to do it. We're going to have it do it 10 times. Now we're going to grab a panel tool. And there it is. There's our list. 0 to 0 to 9, because it doesn't go to 10 because 0 does count as a number in this case. So I have this list, and you notice that this list actually has an index to it. So 0, the index of the list 0 represents 0, the index of 1 represents 1, the index of 2 represents 2. We also change that up if it makes it easier. The index of 1 represents 2, because now I've just changed it, so it steps up by 2 now. We can also step it up by 3, and it steps up in 3 increments of 3. So just like how matrices work, we can take this list and we can multiply it by a number. So we always multiply so a simple multiplication component, which can always be found in the math, or we can double click and type in multiplication. We're going to plug in all those numbers into A. We're just going to divide it by 2. And actually do it. Yeah, why don't you grab this and copy and paste it over. Or edit, change it to 10. A little easier to move. So we're going to take it, actually, we'll do it to 10. That's easier. We're going to grab another panel. You notice now that our list, it took all those numbers and it took and multiplied each one of those numbers by 10. So that's how we can start to manipulate these numbers, because these numbers could always be used as our inputs for points. So let's go back to our construct point. We could always plug that into X. And when it did that, it now created 10 points along the X. So now, and we're output, notice, is now 0, 0, goes up by 3s. And however, our Y and Z remain the same. So we could always now do this. We could actually take this, so plug it into the Y if we needed to. We notice now, wow, that jumped up. Yeah, so now we look at our panel and it goes 3, 30, 0, 6, 60, 0. So it moves that 1.3 over and 30 up. There it is. And then the next one, 3 over, 60 up, or another 30 up, and so on. We actually then could start to, instead of interpolate, we're going to grab a polyline, just like in Rhino. That polyline functions just like Rhino. It's looking for a collection of vertices. And we can also close the polyline if we need to. Sometimes that can come in handy later on. But we can always take that point, we just plug that right into our polyline, and there's our polyline. And we can adjust that, and it changes the line. So these lists get really important because they can create some really complicated shapes really quickly. We could start to introduce sine waves to get a nice curve, or we can get any other like a parabola, and use those parabolas to create curves, or we can simply start to make curves manually through these sliders, or reference points in Rhino to create these curves. There's all sorts of different ways that we can start to generate these curves, and start to change them and change the logic of how they behave. I'm going to let's see. We can also get into, so let's say we like what we've done so far, and I want to get this into Rhino now. Say it's like, all right, I want to start manipulating this in Rhino. It's to the point where I don't need it in Grasshopper anymore. So how do you get something in Grasshopper into Rhino? The best way is to use the component that is referencing what you want, or showing the component, clicking on the component that really displays. Like right now, I don't want any of these points in Rhino, but so I'm just going to unpreview it. I don't really need them in Rhino. I'm just interested in this line that I made. So what I can do is I can right click. Actually, before I right click, I'm going to make it a layer. I'm going to call it we're going to right click on our polyline, and there's our preview, our enable, which actually completely turns off, which we don't want. But then there's bake. Let's click on bake. When we bake, and when it comes up, it's going to ask for attributes. It's going to ask for what layer that we want it, and we're gonna set it to our layer 0. And since it's just one object, we don't need to group it. We always add any text options if we want to, but it's just a simple line. So we're just gonna put it on line, we're gonna click OK. And when we click it, there it is in Rhino. We're actually gonna unpreview this so we can see it. So there's our curve. And notice that how the curve was made. It's using its control points based off the points that we created it. So we always, if we want to later on manipulate it by hand, we can do that as well. So let's say, okay, I don't want the line anymore. I want the points that make up the line. Well, that's easy. So then we've already generated the points. What we can do is we can preview it and we can see, okay, those are the points that we want. And let's just make another layer. And we'll right click it, right click our point from Grasshopper, bake, do that. But this time there's quite a few of them. Maybe we don't want all of them to be clicked individually. We'll group it. Sometimes just to keep things a little more organized. We'll say points, group, yes, please. Click OK. And we'll just unpreview it so we can see it. Oh, there's our points. When we click it, it acts as a singular object because they're all grouped. Maybe down the road we don't want them grouped anymore. So we can just highlight, type in ungroup. And now they're back to the individual. We're just going to turn off those points. Let's say I made this point that or this curve that I really like now. I generate a few things with Grasshopper. I manipulate to the way I want it to be. I really like this. I want to offset this, and I want to start doing stuff with it, Grasshopper. Well, just like what we did with points, we could always reference curves into Grasshopper. So what we can do is we can go into parameters, geometry, and there it is, curve, containing a collection of generic curves. And click on that, we can select it, right click, set one curve, just like how we did our points, click it, and now that curve is back into Grasshopper. Now, important thing is this is a very different curve than what we generated. So if we go back a step, notice that when we change this curve that we did in Grasshopper, it's not going to change the curve that we baked in. It's completely has been disconnected from Grasshopper. And then we manipulated it in Rhino, and then we referenced it into Grasshopper as a completely different curve. So Rhino, these curves have a distinct ID, and that's how Rhino can keep track of these. This is actually really, really convenient because when you're working on a script for a few days and you're referencing things in Rhino, if you open up your Rhino file and then open up your Grasshopper file, it will know which objects to reference because they all have a very unique ID. So you don't have to re-reference your objects all the time. So here's our curve, and we're going to offset it. And we can just either type in offset, or we can go into our curves under utilities. Here it is, there's just a simple curve offset. And we're gonna drag, connect our curve right into it. And notice that it moved our curve over. And we're just going to, yeah, we're gonna keep that there, actually. And it's looking for, and it just offset by 1. Let's change that. Let's do 10. It's offset by 10. Well, that's way too much because now it gets kind of wacky, kind of self-intersects after that. But we can get something like that. We can get a pretty cool curve from there. And let's say let's generate a point on it. We're going to go into the analysis. So we can, there's a couple ways we can do it. Let's do a point on a curve. Evaluate a curve at a specific location. What it does is it gives this little slider that gives us and where this point is evaluated. So right at that point where we just plugged in, that is the halfway point of this curve. We can always change this curve around, change this around, so we know it's 0, 0, 0, 0 at the beginning, and 1 is at the other end. So we imagine 0.1 or 0.5 is halfway. We imagine a quarter is 0.25 is a quarter. We can also set this as well. 2/3. If we have a very specific number that we wanted, we could always go into an analysis, and there's evaluate curve, which is the same thing, but we can always connect a slider to it. And just like this, we're gonna edit the slider so it's similar to that. Loading, and we're gonna plug that right in. And we're gonna unpreview this. And there's, oh, sometimes though, where this happens, if I wanted this, this means that this curve, it's a polyline, but that polyline is made up of segments. So it's just how some of the software is reading. It's what this is doing is it's taking the domain of this curve and it's setting it to 0 to 1. Well, sometimes this gets stuck, and it's like it just gets stuck on this segment. So there's a tool called reparametricize. And what we have to do is right click over this. And we see right click over the C, and it's very, it is important to right click on whatever input it is, but C, we want C because C is the object that's defining the domain, which is that curve. Right click, reparametricize, and now we get our curve back again. It's just sometimes it gets stuck on a certain segment, and it's like, no, we don't want you to look at the segment. We want you to look at the whole picture. So it means redefine the domain as the full line. You guys hopefully won't have to come across that too often, but if you do, it's just a quick thing. But now we got our point. Let's do that same thing. Let's copy and paste this one over. We're gonna plug our curve into this one. Now we got another curve. So what if I want the midpoint of this curve and the midpoint of this curve? I want to create a line from that. Here's our line. So let's say I've worked on this long enough. I'm good for the day. I think this is a good start. So let's say hypothetically I'm done. I feel like this. I think I just want to move to 5 or something. I'm going to save this. It's also really important to save your Rhino file. So a really good practice is to name your Grasshopper files the same name as your Rhino files so they don't get screwed up or confused, because this Grasshopper file, all the objects that I just made in Rhino is referencing that, and it has that specific ID. So if I ever want to use this Grasshopper file again with my Rhino, it's a really good practice to know which Grasshopper file goes to which Rhino file. And I'll show you. Let's go into, we'll save this as a, and we're going to do file. So we saved our Rhino. Now we're going to save our Grasshopper. We're going to click on File, Save, and we're going to, it happens to jump right in the same spot that we saved it. We're going to do, and when we start even type parametric line, it will recognize our Rhino file. So we're just going to click that. We're going to get rid of the 3DM, because if we, sometimes they will do parametric line dot 3dm.gh, which gh is the file extension of Grasshopper. So we just keep a parametric line the same. We'll save it. And there it is. So we got our, so let's close out of this really quick. And when we close out Grasshopper, notice that all the Grasshopper components goes away. And we'll exit our Rhino. And when we want to go back in, we'll open up a Rhino file. There it goes. There's our line. We launch our Grasshopper. We have to load up our Grasshopper file again. Sometimes it's right here, and you can just click the hotkey or the super link, or we can just do open document, click on our parametric line, and when it loads, it automatically recognizes, oh yeah, I remember this line, I know what to do, and I'm back at where I'm doing what I'm doing the next day. Okay. So let's move on to, is there any questions on this? Did I go to
I have
a
a question.
Yeah, what's up?
Are you saying that like you design using this?
Yes, yes. So it's a different way of designing. It is a unique workflow for sure, but it has all the characteristics of what the design process has. Design process, it's a process of things. Just like Grasshopper, there's a logic of things.
So you could also design though, and then pull a Grasshopper diagram or whatever out of the design that you designed in Rhino, and then tweak from that as well, right? I mean,
Yeah. You could, once you have, yeah, exactly. You could always get it to a point where, okay, if I've gotten to a very complicated process and now I bake it into Rhino, and I could further manipulate in Rhino and design it further and not worry about the Grasshopper script. Actually, there's, to show an example of, let's see, so there was let's see if I have this. So this was, I mean, I think I was showing this last class, or the first class this was all designed through Grasshopper. And it was simply define what's the logic, what's the overall logic of it, of the structure, and you just like how we were manipulating those series of points, you can start to define that list of points. What is it really good? What are those points? And it doesn't have to be points. It can be curves. It can be surfaces. It can be really anything you want. This is the most kind of the tough thing about it, is wrapping your mind around what can Grasshopper do. It can pretty much do anything you want it to do. It's just, what's the logic behind it? And that's the key, is you have to have a logic behind this. So like grids are a really common way to start as a design logic, like especially with architecture. It's like structural grids and stuff are very common to use. So this is an example of how Grasshopper can be a great design tool. So this was a design competition that I won. It was for Detroit. Detroit usually has this month of design where they just kind of have all these artists and architects come up with these great installations, and they make a big design competition out of it. And winner gets a few bucks to construct it, and they put it on display. So this year I was able to win, and this was the concept. It was, and the design process it changes a little bit because I have so many options to explore, but it still is rooted with, this is a concept. This is the base logic of how I'm going to design this. And so for this, in this design, we were designing a little 10-foot by 10-foot mini golf course. And what the concept was I wanted this golf course to be a unique experience for anyone, that there is no fixed course, that this course could be changed in any combination I want it to be. And so, of course, we use Rhino and Grasshopper. And so what was the rooted logic? Well, I'm going to divide this golf course into 25 2-foot by 2-foot modules because there's a lot. It's really easy to transport around, and I can start to I can have a module I can work with to shift things around and make a new course if I needed to. So how do I create these modules? Well, I'm going to start off with a grid. I'm going to break these, and in this case, I was inspired by just the curve of the golf ball, just moving along a surface. So it's like, okay, here's this simple curve. And from that curve, I'm going to say, I'm going to have this grid, and it's going to give me a value. If this curve is close to this point, it's going to move this point up a certain magnitude. So that's where it's like, okay, I have an X, and it's going to move up half of X. It's going to take this point, it's measure it, it's going to say Y, it's going to move it up this point, up half of Y. And I have a Z, it's going to move up at half of Z. And so that gave me 4 points up in the center, and used a few components to generate a surface from this. And that created the basic form of my module. So this was just the simple Grasshopper script to generate that module. And this whole thing was controlled by just 3 points. And it was able to get these. So the important thing was I want to generate a lot of these. I need design options, because what makes one module better than the other module? So this was defined by just 3 points. So the 3 points had a domain, and we just ran through every number it could come up with. And what we did was in probably 5 minutes, this script generated 8,124 design modules. And we did design, and just to show you, this is all 8,000 and so design modules. Just the script running through all the different options and giving us how what we could do with it. So it changes things, because now it's like I'm no longer refined to, okay, I only have enough time to design 3 or 4 design modules, and they have to be. And I'm gonna focus my time on this. I have thousands of these. And now the design process is, okay, how can I sort through these? And that's exactly what we did. We took the domain of certain ones, so the input of certain ones. We divided by pars because it was golf. Thought that was cute, but we organized them into 4 categories, and that was just the input of the domain of this. And then we began to lay out these. So we're like, well, since it's a 5x5 grid, we'll grab pars 2, 3, 4, and 5. We have to have our hole, and we're going to have 4 neutral spaces. So those 4 neutral are just 4 blank spaces, like starter spaces, that people can set the ball up on. And just moving those around gave us over 10,000 design options to lay those out. We also wanted to increase the design options more, so you could actually lift these up and rotate them around. So it was just a different way of how you design. It's very similar to how you design. It's just how you change the design based off of tools. And then we had to come up with how we're going to fabricate these panels. And that became a whole nother issue. In fact, this was so actually this gets into 3D printing as well, because our original idea was, okay, we're going to have these design modules, and we're going to laser cut them or we'll CNC machine them out. And we'll lay them onto these 3D printed standoffs. And we thought this was going to be a really cost-effective way. We also didn't have a CNC machine. We had a lot of 3D printers. So we're like, how can we, the tools that we have the most is 3D printers. So let's utilize the 3D printers as much as we can. We're pretty limited with the CNC machine. So let's try to minimize that exposure, that risk. We had nobody to CNC it. We had a few ideas where we could. But this gets into the actual fabrication process of, okay, we had 4 3D printers. 2 of them use the same software. They're all different hardware. None of them really created the same output. We just had to tweak a few things to get them all produce the same output. And the outputs were pretty minimal. Probably this one, this is my personal 3D printer, is this Duplicator 4S. It's pretty old. It's actually, I bought it like 4 years ago, more than 4 years ago. And so the software of it was really dated. These were using Cura. They're more updated stuff. It's just, there's just a few minor logic things of how it created. It still created great 3D prints, but it was just a few minor things. But I had a few issues with this. In fact, during this whole project, I had to completely rebuild this and reprogram it. But on a side note, we used, yeah, that was just a side note. But that's when we started rapidly prototyping these standoffs. And that's where Grasshopper was fantastic, because when we started to work on these little standoffs, they didn't fit right. We had a lot of pieces that had to fit together. So if something didn't fit right, well, we just went to the script, moved the slider, it updated the model, and we just sent it back to the 3D printer. So we were able to generate all these in probably about 3 days. And we were able to test different infills because people are actually going to be standing on this, how durable they're going to be. We actually bought Tough PLA, which is a super strong plastic. We actually, in the end of the day, we realized we didn't even need it because these models were so strong. And this was just simple mock-ups that we were doing, and this was all just through, and all this was scripted. None of this was actually 3D modeled in Rhino. All this was just in Grasshopper. We just baked it and then sent it to the 3D printer. And as we started to design the standoffs, our scripts got much more complicated. And because then we had to deal with screws, because then there was the nut thickness, the print tolerance, the diameter of the holes for these triangles, how we're going to fasten this down. The parameters were getting kind of out of control because also we weren't sure on the substrate of how durable this wood was going to be. At the time, we were thinking it was going to be 1/2 inch plywood. And then at other times, we were thinking, should we switch it to 3/4 inch? Or should we switch to MDF? So all that has different thicknesses. But with Grasshopper, we were able to rapidly change that. And it would update all these little, all our little standoffs. So our panel was getting complicated pretty quick because and also by this time we actually found someone that could, that did have a commercial grade CNC machine that could help us. But with Grasshopper, we were able to monitor all our panels, how many pieces we had to cut, all our parts that we had to do. Everything was through Grasshopper. And we also were able to, with the 3D printing software, we were able to start to predict how long it would start to 3D print. And that became a pretty big issue. But this was just how some of the tests we were putting together. Again, mock-ups. And this, it's just, like I said, rapid prototyping. It's just cranking out these things, testing them, make sure it works out. Um, but we were getting an issue, and this is just an issue with 3D printing in general. And when in this class, we have to be conscious of this, is the amount of time it takes to 3D print. So it takes 64 hours to 3D print one of these panels with all these standoffs. So our total print time was about 1,600 hours of 3D printing. So yeah, that's a lot, since considering there's only 744 hours in a month, and we had 3 months to construct this thing. We did have 4 3D printers, so that did help significantly. But if one of our 3D printers went down, we would be, we'd be stressing out. So there is a lot of risk in this, and this is where the balance between design and fabrication. It's just how do you balance the time that you have, how you do it. That's when we came across people that we partnered up with, which was Mod Interiors, which is a local Detroit fabricator. They were able to help us CNC some things. So we actually kept on trying different woods to fabricate and trying different fasteners. And we were always kind of tweaking little things and trying them. And it wasn't a big deal because we just 3D printed something new and just changed it up. It wasn't wasn't this huge headache to 3D model. Also, each one of these standoffs are unique, and there's 16 of them, and there's 25 panels. So that's a lot of unique standoffs. So just to physically model each one of those would take an ungodly amount of time to physically model them. So that's where, again, scripting, we could update all of those by just moving that one slider. So after contacting with Mod, pretty much our mill time got significantly lower because they just had the professional equipment to do all this stuff. But we actually came up, and again, the design process is never linear. We actually, while we were in this process, we had us, and talking to the fabricators, we had the, wait a minute, what if we eliminated the 3D printer overall? That could save us a lot. Now that we actually came in good terms with the fabricator. They're very generous enough to help us out. They were saying, well, wait a second, we have this CNC machine that can crank these panels out really quick, and you don't need to worry about the 3D printing. This was a huge moment for us because it's changing a lot of what we were trying to do. But from the beginning, we were always limited on our resources, and with partnering up with this fabrication group, our resources grew. So the design became a lot simpler while we maintained the spirit of the design. We also just, risk-wise, if anything happened to the 3D printer, and these were so complex and our schedule was so tight. So it was at this time where we had this departure point where we're like, we learned a lot doing this. Maybe we tried this. We actually found out that we went back to what our original script was, where it was, hey, this is actually defined by just 3x coordinates again, and the thickness of the wood. And we put height increments onto it because we wanted to use 1-inch Baltic birch, and we wanted to make sure all these panels went up 1-inch increments. So our script just became simple again. And that was just them ripping through these panels, which this machine was just amazing on how fast it just blew through this MDF or Baltic birch. Well, in their case it was MDF, but yeah, it by changing our resources, we were able to significantly reduce our panels. It saved us a lot of time and money and headache. And we wanted to do it out Baltic birch because I love plywood. And so we were able to do that with a pretty minimal cost increase. And this is just a schematic way of how we were going to put together. We were going to have a base with a whole bunch of holes so you could change these around. It would have bumpers for the balls and assembled like that. And yeah, that was the finish of it. But for Grasshopper though, I think it fits right into actually like designing this. And it fits right into the design process. The hardest thing is just wrapping your head around it is the parameter part, the numbers part, because we're so used to just, my gut is telling me to move this just like to this direction. Well, with this tool, you have to have a logic to it. And later on in the class, we'll get into an actual like form finding techniques where we're actually going to have the computer assist us in generating the forms and telling us, okay, if you want the best views, we're going to tweak this form to get the best views. Of course, and it's all based off just how well you want to write the script and how detailed it goes. But absolutely, it fits. I think it fits right in. You see a lot of Zaha Hadid architects. I mean, they use that a lot. I mean, it's actually becoming more and more common now. In fact, it's about on average 2% of firms, like 2% of the people in firms use this software right now. But the thing is, we can't find enough people that know this because I mean, we just saw that it can save us a significant amount of time if we had to update each one of those pedestals or standoffs through Rhino. It would take forever to do, and we would be really limited with our design exploration. But with that, since we automated that, it freed up our time to do what we love, and that's design, and not sit around and do repetitive modeling tasks that no one really wants to do. But with that, I'm going to jump right into assignment 2A, which this is how you start to design in Grasshopper. And the very first thing is, actually, the very first thing you want to do is model the problem. So there's a logic to that problem. There's something that's happening. And in this scenario, we're going to look at zoning. So a common thing in architecture are yield studies. What a yield study is a developer is coming to you and it's like, I have a plot of land. I have something I want to build on, and I want to make sure I want to build the most I can on this property. So in this introduction, we have as developers like, hey, I got one of 5 lots, and I want you to pick one, and we're going to perform a yield study. I want to see how much square footage I can build on this, and or what's the maximum I can go. What's the maximum gross area I can build on this, and what's the maximum number of stories I can build on this lot. So the first step when we do this is we're going to have to look at the zoning. And I've included the zoning, and this is something quick I wrote. But we have our setbacks for the site, and we have our floor area ratio. So our floor area ratio is the area of the site times its percentage. So in this scenario, we can build 36 times the area of our site. However, we have to follow these setbacks for our property. There's also incentives as this is for this as well. A lot of cities do this where if you're building a LEED building or a green building or something that, or maybe it's a building that's beneficial for the community or has a feature that's beneficial, they'll give you bonuses, they'll give you premiums. So in this case, in our scenario, we have a developer who wants to build a LEED Platinum building. And based off the city, that's going to give us a 500% increase of our lot. And that's 500%. That's 36 plus 5%, plus 5. It's not a 36 times 5. So with the files that I've uploaded for assignment 2A, you're going to find a city. We're going to have 5 red rectangles. I want you to pick one of those 5 rectangles, and that's the site that you're going to perform the yield study on. Also, a part of the assignment is this Grasshopper file, this blank Grasshopper file. All the components you would need to complete this yield study, or part of this yield study, is in this. All you have to do is connect these into the correct order. And everything that I showed today is what is pretty much the same as what you're going to do here. So it's and once you do that, once you connect all these together, I'm looking for what you guys will submit. So I'm looking for a high-res image of your Grasshopper script that should have your maximum gross area and your maximum number of stories on it. And they will appear, if you did this correctly, they will appear, oops, yeah. They would appear here. Gross area square footage with premium, maximum number of levels. And all these should be filled in with the correct numbers. So we also want a high-res image of your Grasshopper, which I'll show you in just a minute how to do. And I want an image of I want you to grab a perspective view of your site with all the Grasshopper components turned on, and grab a cap, and you captured a file, that image. And then combine those 2 images into one PDF with your name on it, and that's assignment 2. So real quick, when we get into to export, so really what we want is we want to do file. Yeah, so to export this as an image, you want to go to file, and it's right there, export high-res image. So we do have that design standard for that. I want you guys to reference for Grasshopper scripts. So we do that. If we slide the A channel, we have a white background. If we slide it to 0, we have no background. It'd be a PNG. Either way is fine, because I'm assuming you're going to have your background or the sheet that you're placing on is white. In this case, it doesn't matter. But in this case, we'll just do 100 or 255. And this is our image file. Click this, the 3 dots. Its default is PNG. We'll do modules. We'll do test. Save that. That sets up the destination. We'll click OK. it'll run through a little script. And there's our grasshopper. And that's all I want. It's just a nice high-res image. So it's important for a high-res so I can zoom in, make sure, check on your panels and everything's reading correctly. So one other thing that might, sometimes this may happen, and this is also just a good thing. So what I did for each of these is I broke up all these into line segments. So when it says front property line, I'm assuming the front property line will be facing this main street. You know, this will most likely be a main street. Probably not that one because it's so small. Same with this one. This will probably be a main street. This one would probably be a main street. This case is probably this one, I probably would just classify that as a main street since it's just so small. But as what we mentioned before, so if we right click on it, we'll say set to one curve. We'll select that. And that's how we start to get these, does start to define our property. So our side, say right click, set that one. Set that. We'll reference our curve there. And our rear. And they go into an offset. But sometimes if we do an offset here, and also let's so that's our side lot there. And so it's going to ask for a distance. How far is our distance that we need a setback? Well, let's reference, go back to our assignment. Side setback, 15. We also want to double check our units. I believe the units the file I gave you, the default units are in feet. So just keep that in mind. So we don't have to do it 15 times 12. We can just type 15. It gives us our slider, or we can right click on this, type in 15, or we can do a panel, do 15, either one. And we're going to plug that right into D, and it shifts over. Sometimes this will happen where the D, sometimes this line offsets outside the property line. We don't want that because it doesn't make sense. The setback is not in your property line. So sometimes that happens, and to reverse that, it's pretty simple. We have that. Let's pretend like this went the wrong direction. All I have to do is add a negative to it, and it flips it. So remember, we always want the setback to be in our property. It doesn't make sense to have it in someone else's property. But this is a very real situation that we deal with at work is yield studies, and in the root of them is all about numbers. What's the most I can get out of this? What's the most square footage I can build out of this? And then once I have that square footage, I can start to put a pro forma to that. And then I can start, and we can start to give that information to the developer, and the developer can start creating a pro forma, understanding their budget and what they can do and how much money they're going to make from this property. It's also all rooted in numbers, which is fantastic for Grasshopper because it's all about producing numbers and watching them. Now, this isn't the only application for this. There's, like I said, with the whole putt-putt thing, but it's this is something that seems to gravitate a lot towards it because you can generate these very quickly. And also, a lot of times, architecture firms do this for free. So of course it's a risk for the architecture firm because they're like, hey, this could be a huge project for us. Yeah, we'll do you a favor and we can do a quick yield study. So it's always like, how fast can I get this? Because it's money out of my pocket, but it could be a great job and I could just get that. So it's usually I want to crank this out as fast as I can, but have these numbers that are really that are solid. But there's just a lot of repetitiveness to some of this. So that's where it's great, where when there's a lot of repetitiveness and it deals with numbers, Grasshopper is a great program to help solve that. I've written a script where it's just like if we needed hotel rooms or student housing or apartments, we can define the site, get the site backs, and it spits out a 3D model of all the units. What's the unit mix? This is the most number of units you can get on it. With this kind of unit mix, this is how you get an optimal development. And it's all done very, very quickly. So again, this is just the first assignment, nothing. All the components, probably minus the number sliders, are all here. You really just have to connect them together. In this case scenario, you're going to come across a few scenarios where you'll have a polyline and it's looking for points, and we have 4 separate collection of points. Well, one quick way to do that is we can drag our line here. Actually, I'll do this let me do this here. Because this is one thing that you guys will probably need to know. So if I have point here, point here, point here, point here. And there are 4 separate points. Four separate points here. And I have a polyline, just like with a loft or anything, the order of how I plug these into my polyline matters. So if I plug this one point in, and then I hover over this, I hold shift. And I have to hold shift, and what you notice when I hold shift, the arrow turns green, I get a plus on it. I'm gonna click and drag, and I can plug multiple parameters into a single component. So I'm gonna hold, shift, plug, hold, shift, plug in. And so now I have all 4 of these points that are inputting into this vertice, into this polyline. Now order matters. It's very important that you plug these into the order that you want, because I could do this one, hold shift, and see now the order is different. So it's just keep in mind the order of how you want these to be drawn, because it does matter how it is, how it creates the line. So But yeah, I think, yeah, does anyone have any questions?
On the Grasshopper file that you have there for the assignment, do we need to rearrange the nodes in any way, or is it just connecting them, adding in our sliders where we need?
You can, I mean, you can rearrange them as I arrange these just by the logic of how they're going to go in, so that there's could be some clues that you can get from there. So like, you know, the curve will most likely go into the offset. The offset will most likely go into one of these. But you can shift them around any way if you want to. And if it makes more sense for you to shift them around, I personally, for this example, I like to position my points based off the order of them. So if I'm trying to draw a box here, like I like to say, okay, where's this point? Okay, I'm gonna move this point here. Where's this point? I'm gonna move this point here. Where's this one? I'm gonna move it here. Where's this one? So it's just, for me, it's a lot easier to just be like, all right, I want this box. Oh, oops, I screwed up. Oh, my bad. I haven't drawn a box in a while. And then notice that we're missing that one leg. We could always right click on this. Notice that C, closed, false. Just right click on that and say that's set to true. And it draws that extra leg. So you could do it like that. You can also label it. So you don't have to just have it say PT. You can say have it called point A. Or you can have it called point B. So you can move them around, you can label them, do whatever you need to do for what you think it makes sense for you.
Could you explain the floor area ratio again? I think that went over my head for a second.
Yeah. So let's see here. The floor area ratio is, if I have a rectangle, that's my property, right? So that has, we'll just grab. So I'm downsize this thing real quick. So this is our site. Pretend this is like our property line. So the cities, they have what they call a floor area ratio, or in short, they call it FAR. And what that does is it controls the density of the city. I don't want to get too much into this because it's all about urban planning, but it controls the density of the city. So, so if we have a FAR of 200%, or sometimes they'll say 2, in our scenario, we'll say 200%, it's twice the property, it's twice the area of this property. So if we just grab a quick multiplier, and we'll grab us, we'll just grab a quick panel. And for the assignment I did, 200% for as a label, but we can just put 2 in. We plug that in. That is our most that is our maximum buildable area that we can build a building on. So the biggest building I can build on that site is 748,000 square foot. I can build a building that big, but I only have 3,740 or 374,000 square foot. So how do I get the maximum? How do I maximize my square foot? Well, you just have to build up, right? So I want it, so it's technically 2 floor plates. I can, if I wanted to, I could build max out the site and just build it 2 stories. However, the city is like, well, we're going to give you setbacks, and setbacks are really important because it gives us, and setbacks give distance between the buildings. It gives, that's what generates the alleys. It's for maintenance, it's for utilities, it's for service. It's also important for the people experience because, a lot of times, if you want to have all these restaurants that have, sidewalk dining and stuff, well, the setback's going to be set back from that property line. So we really can't build all the way to our property line. We have setbacks. So in this case, I'm just going to do it quick. We're just going to say, in general, we'll have an offset of 30 feet all around, and it's usually not the same. And so, see, sometimes it does it out. We want it in, so we're just going to do it quick. Delete this and do a panel. We'll just say negative 30. So there, so we have 30 foot. So technically, our, what did I say, buildable square footage, or so technically, since we have a 30-foot setback, we can't build right next to, we can't build all the way to our property line because we have a setback. It's just like your house. Like there's like when you're in a neighborhood, there's always like a 15-foot or a 5-foot setback between each house. It's like, okay, you can't build there. You can't build right next to the house next to you. You have to give it a setback. All that's controlled through the city. So in this case, we have 30 feet setback all around the perimeter. So technically our buildable square footage is 303,000 square foot. So how many levels can I build on this? So you really just take area, a simple division. So we want max so that is, so if we took our buildable area or our maximum area that we can build on and we divide it by our buildable, we can build 2 stories. Now we can't build 2.4 stories. We have to just go it's just solid 2 stories. But but the nice thing is about having this all parametric, because what if later on we pick a different site and our setbacks are different? What if it's really different? What if it's actually something absurd? So now we know is, oh wait, I can actually instead of 2 stories, I can actually build 4 stories now. So that's the buildable area. And I don't want you guys to get, hopefully you guys don't get too confused by that. I did, let me know if you want more information. I did label all the things that, all the city stuff. So not to get you guys hung up on it. I really just want you guys to get focus more on the logic of where it goes, but where these are connected and how some of these are going to work. But let me know if you have any more questions on some of that. Some of this is just is based off how big the building can go and the density of the building. And it's all interconnected with, okay, if one variable changes, then it's going to create a cascading effect, and it's going to affect the overall performance of the building. So we deal with that. A lot of that is dealt with in architecture, working with the city, working with the zoning. There's so many things that the building has to go through, and and also this is a fantastic thing for code, because code is all based off a lot of these numbers and allowable square footages and maximum runs. But this is just some really simple zoning stuff that occurs when you practice architecture and you have to work with the city. So I hope that does that help? Okay, great. Any other questions?
John, going back to assignment 1, that's due on Thursday night now?
Yeah.
Okay.
Yes, yeah. It's on Thursday night. It's Thursday at midnight.
Okay.
Or 11:59. Great. Anything else? Great, guys. Let me know if you have any questions. I'll talk to you guys next week.
Sure.
All right, great.
Thanks, everyone.
Thank you.
Have a good one.
You
Bye.
too.
Yeah.